So today we're going to talk about resistivity and how kind of it is. So as an example, so let's say we have two exact wires that the diameter is exactly the same, however the length here is larger. So where do you think is going to be higher the resistivity? Resistivity is basically how easy the metal conducts electricity, lets it pass through basically. So the answer would be here, and the reason for that is the electron, it would need to go past more positive ions. So that's why over here the resistivity is larger than here, because over here it would just have to go like this. Over here it has to go more of a distance and pass more of the positive ions, of course. So the resistivity is proportional to the length of wire. So now this time the lengths are exactly the same. However, this one, as you can see, it has a larger diameter. So what do you think does that mean? Will the resistivity be higher or lower? Remember, resistivity is how easy it goes through. So where do you think the electron will go through more easier? The answer is the big one. The electron has more ways to go through in the metal. So the higher, the bigger the cross-sectional area, the lower is the resistivity, because it's easier to go through. However, it's not all about the size and the shape. It's about also the material itself. So we have two examples: copper and steel. Copper is a good conductor. It has very good, very low it has low resistivity, and steel is a poor conductor. The symbol for resistivity is Rome, something like this, but and we know that resistivity is proportional to length, and inversely. So inversely, when I say over here, if the length is bigger, then the resistivity is higher, and when I say inversely, that means it's lower, technically, basically. About the area, having resistivity as a subject would be, so technically I switched all the two places. The unit for resistivity is going to be the ohms meters. So that's the unit, ohms meters. Resistance, which is in ohms, and we have the area, which is in meters squared, and the length is meters. So, and because meter squared is basically 2 meters, so this cancels out and this cancels the square. So that's how we got it. The difference between resistance and resistivity is how much opposes the flow of electrons. So basically the electrons, right, in resistance, it's about the size, and it's about the material, if that makes sense, what's made out of, the substance. So it's kind of like a geometric property. However, the resistivity is a intrinsic property. So what I mean by that, so let's say, right, we have a material, right, and I doubled the length. The resistivity, it doubles, and let's say I increase the cross-sectional area, that means that the resistivity halves. Let's say in a material the resistivity is something let's say for copper, for example, 1.7 times 10 to the power of 8 ohms meters. Let's say this is the resistivity, right? Even though it doubles and halves, it doesn't change. So for the material, it doesn't change it increases, but like in general it doesn't change. So let's just quickly go through the main topics just so we refresh our brain again, blah blah blah. So this is the formula, and if you increase length, the resistivity will go up. However, if you increase the area, the resistivity will go down. So here are the resistivities, and where do you think is the lowest resistance? You can see copper has higher resistivity than silver, which means if the resistivity is higher, then less electricity can go through, which means it's like silver is better. That was actually a perfect one. How did I just do that? Okay, basically PT equals PO bracket 1 plus alpha, which it's kind of like this. So alpha and a bracket T, take away TO, bracket closed, and another bracket that closes this one. What does stuff mean here is this the previous resistivity. A 1 alpha is what's in the question, what we would see, and these two are the temperatures, and this is like the final, what we need to work out. So why we're talking about this is, let's say for metals, if you increase the temperature, the resistivity of it increases. So here's an example question. A 15-meter long copper wire has a cross-sectional area, a radius of 3 millimeters. So our first question is, what is the resistance of the wire? We're given the resistivity, which is this, and it tells us that's at 20 degrees Celsius, and we are given the alpha. So since we're talking about like finding the resistance, the equation that we're using is R equals the P, I'm just gonna call it P from now on, over A. So let's just quickly draw what's happening. So we have the wire, right? And basically the length equals 15 millimeters. So the area is in 3 millimeters. We need that in meters. So we can just divide it by 1,000, or in the calculator, what we're able to do, we're able just to write pi 3 times 10 to the power minus 3 and then squared, and then let's just put all in the calculator. So R will equal 1.6810 minus 8, because again, we're given it here, guys. Then that's by 15, and then divide that by the pi, 3 times 10 to the power minus 3, and then square that. So that is 0.008913 ohms, because remember, resistance is in ohms. The way we find the new resistance of a different degree is equals previous R, so R0, bracket 1 plus alpha times T minus T0, original temperature. So we have the resistance at 20, which is 0.008913, and then we do the 1 plus, we have the alpha. The alpha is 0.0068, and then we do 50 because that's what we want to find, and then we take away that 20. So the answer of this will be 0.01073 ohms. Our next question is, if 200 milliamps of current flow through the wire, what is the voltage drop of the wire at 20 degrees? Convert this into the proper what's called current. So milliamps, so this times 10 to the power minus 3. So V equals IR. So that will be V equals 0.2 times we have the resistivity over here because it's asking for the 21, and the answer is 0.0017826 volts. So this is the voltage drop per 15 meters, because that's the length of the wire. Let's convert it to millivolts, so we can do 1.783 millivolts, because remember, like, milli equals 10 to the power minus 3, and rounding that up, basically that's what it gives us. Now what is the voltage drop per meter at 20 degrees? So what we do for these, we just divide this by 15 and we get 0.19 millivolts, because it's in milli, so we keep it in millivolts, and that will be per meter. We just answered all the questions, but let's say then it asked what if the wire was 300 meters. We would just times this by 300, because like this is just per meter, so I think you should get it as basic knowledge. So the next example question that we have, a copper wire, we're given the alpha is connected to a 12 volt battery at 20 degrees Celsius and conducts a current of 0.45 amps. At a new temperature, the same wire conducts a current of 0.41 amps. Is the new temperature higher or lower than 20 degrees Celsius? That's our first question. So let's think logically. The current decreased, which means the resistance increased. The copper is a metal. What happens, like, when do metals increase the resistance? When the temperature increased. So the answer to this is yes. And now we ask, what is the new temperature? So at 20 degrees, we can use V equals IR to find the resistance, because it's not given, so we should find it, and the resistance equals VIR, so 12 0.45 equals this in ohms. And the reason we're looking for resistance is it's like basically siblings of temperature, because like if it increases or decreases, something happens to resistance. So now for the new one, the voltage is the same. We have the 0.41, the current for it, and the answer for the new one is 29 ohms. So what we can use to find the new temperature is the R equals old R. I'll just write it down first. 1 plus the alpha, and then the temperature, and then the old temperature. Old resistance was 26.667 plus 1, and then the alpha is 0.0068, and then that is times by the new temperature. We need to know the old one, and I forgot to mention that all this we already know was the new resistance. It's equal to this, so the T minus 20 is divide both sides by 26, because over here there's a times, so we need to divide to get rid of it on this side, equal to 1 plus 0.00068 temperature minus 20. So now it's just a matter of making everything the T subject. So let's get rid of the 1, so 0.0975. So 0.0975 divided by 0.0068 equals this, and then this is equal to 2 minus 20, and then we just add the 20, so 34.33. A equals T. So this is the new temperature, and this is all for today. Thank you very much.